Okay guys, so here's the video for the post-test review. There are 8 total questions, so it's not very many. And here are some of the topics that it covers. So radius, diameter, perpendicular parallel lines, naming angles, dilation and scale factor, horizontal and vertical stretches, reflections, and then orientation of a graph. So this review is not going to be very long. It's just going to touch a little bit on each topic. So radius and diameter. So remember, if we have a circle, and we have the center of our circle right here, the distance from the center to the edge, that is our radius. The distance from edge to edge that passes through the center is considered the diameter. The diameter is double the radius. So 1/2, if I were to divide the diameter in half, that would equal the radius. The other way you could do that formula, if you double the radius, that gets the diameter. So that is that connection. Remember that. Perpendicular and parallel lines. So this is the symbol for perpendicular. This is the symbol for parallel. If lines are perpendicular, they form a right angle. If lines are parallel, they will never intersect. And hopefully you remember from Algebra 1, they have the same slope. Okay? Naming angles. Let's throw an angle out here. Let's put an A, a B, and a C. Now, I can name that angle in 2 different ways, but the vertex of the angle has to always be in the middle. So, I could name this angle ABC, angle ABC, or I could name it CBA. Both of those are okay, but notice that the vertex is in the middle for both. Okay? You could also technically name this angle B because there's only one angle. Like we only have one angle right here. As soon as you add another angle by connecting an array, you can't just name an angle B because we wouldn't know which angle you're talking about. So that's important to remember. Vertex, angles named by the vertex in the middle. Dilation and scale factor. Remember, scale factor is usually used with K, but it's not always. Now, if your K is greater than 1, that is enlargement. It means your figure is going to get bigger. If your K is less than 1, that is reduction. The figure will get smaller. With dilation, all you have to do is multiply every x and y by the scale factor. That's it. So if my point is 5, 2, and my scale factor is 5, my new point would be 25 and 10. Just multiply it by 5. Horizontal and vertical stretch. Horizontal stretches literally horizontal. Vertical stretches vertical, up. Now, just like dilation, when we dilate, we're doubling or tripling or quadrupling the size of the figure. With a horizontal and vertical stretch, let's say I have this segment right here, segment AB. That length is 2. If I'm going to stretch that by doubling it, then each point is moving the double amount. But that also means, right, that the distance between A and B should double as well. So that means that if I'm only stretching B, that would move double the amount. So B prime is now 4 units away from A, and B originally was 2 units, because that's a horizontal stretch. If it was a vertical stretch, notice they're on the same, they would both move up the same amount. So 2, 3, 4, or whatever. Okay. Reflections, remember you need a line of reflection. A line of reflections can be horizontal, they can be vertical, they can be diagonal. Biggest thing is they are equidistant. So this is A, I'm reflecting horizontally. That's A prime. They're both equidistant. Equidistant. Okay? If I was reflecting the red dot diagonally, it'd be somewhere over here. Vertically, somewhere over here. Last thing, the last question is about the orientation of a graph. Okay? Just remember that if you have a coordinate plane, something like this, the origin is at 0, 0. Each one of these is 90 degrees for a total all the way around of 360. I will give you a hint. A clock has an orientation of 360 degrees. That's a little bit of a hint for that last question. Good luck on the activity. Good luck on the post-test. Let me know if you have any questions.